Am I audible? Amna and Mariam.
Yes, sir.
We did till dipole moment in the last lecture, yes or no?
Yes.
Yes.
Okay. उसके बाद नेक्स्ट लिखिएगा बॉइलिंग वन डायपोल मोमेंट पॉइंट में लिखिएगा सिंस haloarenes are polar, their point is greater than parent hydrocarbon. The boiling point is so higher due to large molecular mass. ठीक है तो halo will have larger greater boiling point than alkenes है ना halo alkene का ज्यादा होगा alkene का कम होगा if I talk about if I talk particular halogen atom for a given halogen for a given halogen atom the boiling point is directly proportional to the number of carbon atoms. So basically, CH3, X, CH3, CH2, no matter what the X is hiding, I mean, whether it is iodine, bromine, chlorine, if you have CH3, X, CH3, CH2, X, CH3, CH2, CH2, X, or if you have CH3, CH2, whole thrice, and then halogen. Okay, then in all of these, the number of carbon atoms, if I have the number of carbon atoms greater here, the boiling point will also be higher. Now, for a given alkyl group, if the alkyl name for a given alkyl group, boiling point is directly proportional to molar mass of X, the molar of halogen atom. That means if I compare alkyl chloride with alkyl chloride with alkyl bromide and alkyl iodide, since R is same, I have to compare Ri, Br, Cl, and F. Iodine is heaviest, that is why it will be having the highest boiling point, followed by bromine, chlorine, and chlorine. मतलब कि for example, if I have two carbon atoms and chlorine, two carbon atoms and chlorine, two carbon atoms and bromine, and two carbon atoms and iodine, so this is going to have the most molar mass after that this, after that this. Copy this down, raise your hand if you're done. रेज योर हैंड वंस you're done guys, जल्दी लिखिए. Next is, if you have same number of carbon atoms but branching increases, then boiling point, it is inversely proportional to branching. For example, we have four carbon atoms and bromine, again four carbon atoms and bromine, again four carbon atoms, and then one bromine. And as the branching increases, the boiling point will decrease. The highest boiling point will be for the normal. After that, there is one branch, and then we have two branches. तो लिखिएगा. Arrange each set of compounds in order of increasing boiling point. Number one, bromethane. यहाँ पे आपका आईयूपैक नॉमेनक्लेचर काम आएगा. ब्रोमोफॉर्म, क्लोरोमीथेन, डाईब्रोमोमीथेन. Bromomethane is CH3Br. Bromoform is CHBr3. Chloromethane is CH3Cl. डाइब्रोमोमीथेन इज CH2Br2. ठीक है, लिखिएगा मत प्लीज, ध्यान से एक बार समझ लीजिए, देन यू कैन इजीली डू इट. लेट्स सपोज दिस इज ए, दिस इज बी, दिस इज सी, एंड दिस इज डी, एंड वी हैव टू अरेंज देम इन द increasing and decreasing order of body point. Do with you. Okay. So in this case, you can see all of these are having one carbon atom. That means you have to see the halogen. Wherever you have greater molar mass, that will be having higher boiling point. So the greatest molar mass will be with bromoform, that is B. B का सबसे ज्यादा होगा, है ना. After that you have bromine का सबसे ज्यादा होता है ना. If I compare chlorine, bromine, and iodine, so the highest molar mass is of bromine. Where do we have the max number of bromine? In the B structure, then in the D structure, the A structure, and then in the C structure. So this is the order. Second कीजिएगा. Second one, do it on your own. 1-chloropropane, isopropyl chloride, and 1-chlorobutane. ये भी सेम प्लीज बताइएगा. आइसोप्रोपाइल, एक बार एक सेकंड रुक जाइए जरा. दिस इज आइसोप्रोपाइल. बताइए, आमना, मरियम एंड ताहा। अरे बाप रे, ऐसा सन्नाटा छाया हुआ है यार, नहीं समझ में आया तो प्लीज कोई बता दो। चलिए ठीक है। ताहा एंड आमना करेक्ट। फर्स्ट ऑफ ऑल, सी क्लोरीन क्लोरीन क्लोरीन, दैट मींस हाइड्रोजन इज नॉट गोइंग टू मेक एनी डिफरेंस। हाइड्रोजन का नंबर ऑफ कार्बन एटम देखिए, है ना, कार्बन एटम ज्यादा तो बॉइलिंग पॉइंट ज्यादा। So you can see C is having the highest boiling point. ये इसका स्ट्रक्चर क्या होगा, वन क्लोरोप्रोपेन विल बी वन टू कार्बन एटम्स। चलिए, मरियम लोहानी तो इतनी दिन बाद आ रही है आई थिंक। सी कार्बन एटम्स एंड देन क्लोरीन, सी कार्बन एटम्स एंड क्लोरीन हियर, फोर कार्बन एटम्स एंड क्लोरीन हियर। So C will be having maximum, followed by A because of less branch than B. Copy this down. ठीक नहीं लगेगा। Waiting for Amna and Mariam. Mariam, can you please turn your mic on, Mariam? Mariam, can you please turn your mic on? How are you? आप कितने दिन बाद आ रहे हैं क्लास, मरियम?
सर मैंने ज्वाइन करा था।
लास्ट टाइम क्या था आपने ज्वाइन?
जी सर, मैं रेगुलर ज्वाइन कर रही हूँ इधर।
पक्का?
जी सर।
डाइपोल मोमेंट तक किया हुआ है आपका?
जी सर।
तो भाई आंसर आंसर कीजिए, हम भूल जा रहे हैं, आप है ही नहीं ऐसा लग रहा है हमको। हाँ,
जी सर।
ठीक है। समझ में नहीं आ रहा तो प्लीज लेट मी नो, ओके।
जी।
चलिए नेक्स्ट देखिएगा, थर्ड वन इज मेल्टिंग पॉइंट। Is right, melting point depends on two factors. Number one, intermolecular force of attraction. That is going to be directly proportional to dipole moment. Because जितना ज्यादा पोलर होगा मॉलिक्यूल उतना ज्यादा फोर्स ऑफ अट्रैक्शन होगा, ठीक है। So dipole moment is what is going to directly measure what is the dipole moment. ठीक है, dipole moment can directly measure what is the polarity. The second thing that is very important is the packing. How effectively is the molecule fit in a particular structure? Because when you are having solid, then in solid you will be not having too much intermolecular spaces between the molecules. There will not be too much space. That is why if the packing is efficient, if there is less gap in the packing because of the shape or the structure, then in that case the melting point is higher. Meaning when you are going to have symmetrical structures, please write with me, symmetrical structures have have better packing, have better packing. ठीक है, तो बेसिकली ध्यान दीजिए जरा। If I compare chlorine and chlorine like this is para dichlorobenzene, this is ortho dichlorobenzene, and this is meta dichlorobenzene, ठीक है। तो both of these, for example, if I talk about the ortho one, then here chlorine and chlorine, they both have certain dipole moment, और जिसका एक resultant निकलेगा somewhere in the middle like this. Similarly, there is dipole moment for this chlorine in the meta positions also. और इन दोनों के बीच में एक निकलेगा something like this. ठीक है. Now, if I see the dipole moment of para position, then in that case the mu net is 0. Now, this is non-polar. इसमें dipole moment है ही नहीं. These two, they are having dipole moment. Mu net is greater than 0, and these molecules are non-polar. ठीक है. So the logic says that the polar ones, non-polar, ये these are polar. My bad. These are polar, है ना? The polar ones, that is the ortho and the meta isomer of dichlorobenzene, will have higher boiling point, because वहाँ पे polarity है positive negative. There is positive negative parts, positive and negative fragments in the molecule itself. मॉलिक्यूल के अंदर ही पॉजिटिव नेगेटिव है, तो पॉजिटिव नेगेटिव एक मॉलिक्यूल का, पॉजिटिव नेगेटिव दूसरा मॉलिक्यूल का, दे आर गोइंग टू हैव सम इंटरेक्शन. बट experimentally it was seen that the para dichlorobenzene is having higher melting point. Why? Because it effectively packed. इसमें symmetrical structure है, तो packing effective हो जाएगी. In the sense the packing will take place something like this. इस तरह से पैकिंग हो जाएगी फिट, बिल्कुल. वेरी लेस स्पेस इन बिटवीन ना, इस तरह से बिल्कुल पैकिंग हो जाएगी, एंड दैट इज गोइंग टू बी वेरी हेल्पफुल. समझ में आ रही है? तो नेक्स्ट पॉइंट लिखिएगा. ड्यू टू सिमेट्रिकल स्ट्रक्चर of p-dichlorobenzene, it fits in packing efficiently, and hence has higher melting point than its O and M isomer. Raise your hand once you're done. Raise your hand if you're done, guys. Waiting for Amna. फोर्थ लिखेगा solubility. Is right. Haloalkane are immiscible in water even though they are polar. ठीक है, इसका रीजन सुन लीजिए जरा. Why halogens are immiscible in water even though they are polar? What's the meaning of like polar होने से क्या हो जाता है? प्लीज ध्यान दीजिए. So water, it has intermolecular hydrogen bonding, some as you can say. This oxygen atom is more electronegative, that is why it is going to pull electron density and make the hydrogen delta positive. So where this oxygen will be delta negative, the hydrogen will be delta positive, this will be delta positive. तो अगर ध्यान से देखिए, this delta positive and negative are going to interact with each other and this is known as hydrogen bonding. ठीक है. अच्छा, यही सिमिलरली यहाँ पे भी इंटरेक्ट करेंगे इस तरह से. ठीक है. नाउ when water molecule, in the water molecule, if I am going to alkane, then something like this is going to happen. So X will have lone pair and X is more electronegative, that is why it will have delta negative, and the hydrogen will be having delta positive and delta positive. So these are going to interact maybe, है ना. पानी हैलो एल्केन से इंटरेक्ट क्यों करेगा? अगर पानी के पास पानी है इंटरेक्ट करने के लिए, तो if water is interacting or if it is getting attracted by the haloalkene, then that means the attraction of haloalkene should be higher than that of attraction between the water molecule. But this is cannot happen. Why? Because haloalkane is just polar, but in water we are going to have hydrogen bonding. Now hydrogen bonding को छोड़ के वो dipole की तरफ क्यों जाए? Because in hydrogen bonding you will be having higher positive and higher negative charge leading to greater attraction. Does it make sense? Yes or no, please tell me. In hydrogen bonding you will be having greater charge, greater negative charge leading to greater attraction. ठीक है. So the water molecule will never leave the hydrogen bond and make a bond with polar. ठीक है. तो इसी चीज को लिखेगा when haloalkane is dissolved in water, new interactions come into play between water and haloalkane. This new force of attraction between water and haloalkane is much weaker than hydrogen bonding between water molecules. Hence, haloalkane is immiscible in water. But we can dissolve. We can write Rx, that is means haloalkane, are soluble in organic solvents. Copy this down, raise your hand. Done. hand if you're done, guys. Sorry, guys, I got disconnected. Right, the next topic, chemical. Please write with me. Haloalkanes primarily the following reactions. Number one is nucleophilic substitution. Second is elimination reaction. Third one is reaction with metal. इसमें सबसे पहले we are going to learn about nucleophilic substitution, then elimination reaction, और उसके बाद आखिर में we are going to learn about reactions with metal. ठीक है, नंबर ए आप डालिएगा. Nucleophilic substitution reaction. Please write this with me. So explain करेंगे इसको. A reaction in which a group of substrate is replaced by a nucleophile. I hope you guys remember what is nucleophile. Nucleophile is something that is nucleus loving, and in nucleus we have positive charge. That means nucleophile will be electronically rich. Substrate is replaced by nucleophile. It's called nucleophilic substitution. Denoted by SN. ठीक है, तो इसमें आपको बता दें what is substrate in which a group of substrate, ध्यान दीजिएगा, substrate is basically organic reactant molecule, organic reactant molecule. Here it is what? Haloalkene. Here RX. Now nucleophile. What is nucleophile? न्यूक्लियोफाइल होता है आपका, न्यूक्लियो का मतलब न्यूक्लियस, न्यूक्लियो का मतलब होता है न्यूक्लियस, और फाइल का मतलब होता है लविंग. Now obviously if something is nucleus loving, then it will be what? Electron rich species, and it attacks on carbon atom. Carbon atom पे अटैक करता है. Electron rich species attacks on carbon atom. तो बेसिकली यहाँ पे आपके पास RX प्लस न्यूक्लियोफाइल. Now nucleophile is what? Generally nucleophile को negative charge से show करते हैं. Now obviously it is going to have high electron density, so either it is going to have negative charge altogether, or it is at least going to have a lone pair of electron. Until a lone pair of electron, it cannot attack on the carbon atom. और किस कार्बन, किसी भी कार्बन पे अटैक नहीं करेगा. It is going to attack on a carbon atom which is having a delta positive charge, as because hydrogen atom delta positive carbon पे आ ही जाएगा. So basically in the reaction what happens? Basic reaction क्या है? The RX bond breaks and RNU bond is formed. और साथ में आपको X मिल जाएगा. ठीक है, तो प्लीज ध्यान दीजिएगा. इन SN nucleophilic substitution, in SN one base is replaced by another base. अच्छा, base क्यों कहा जा रहा है? Because base is something, if I just give me a second guys. सॉरी गाइस, आई जस्ट गॉट द कॉल। हाँ, वन बेस, भाई हाँ, बेस तो आपके पास क्या होगा? एनीथिंग विच इज इलेक्ट्रॉन रिच, दैट इज गोइंग टू बी अ बेस। यहाँ पे न्यूक्लियोफाइल इज आल्सो इलेक्ट्रॉन रिच, द हैलोजन एटम इज आल्सो इलेक्ट्रॉन रिच। तो एक बेस यानी कि हैलोजन को कौन रिप्लेस कर रहा है? न्यूक्लियोफाइल। द इनकमिंग बेस, प्लीज राइट विथ मी, द इन बेस is called nucleophile, and the outgoing base is called leaving group। ठीक है, बहुत सस्ता सा सवाल है। सवाल लिखिए, आइडेंटिफाई द न्यूक्लियोफाइल एंड लीविंग ग्रुप इन फॉलोइंग। ठीक है, देखिए जरा, आई विल राइट न्यूक्लियोफाइल एंड आई विल राइट द लीविंग ग्रुप in the first reaction, as I hope you can see that this is the nucleophile। अरे हाँ या ना बताइएगा प्लीज, है ना, yes or no, please tell me। अभी बताइए, फिर आप लोगों को ये करने नहीं आएगा तो फिर दोबारा बताना पड़ेगा। मरियम, आमना एंड ताहा, आई नीड योर अटेंशन हियर गाइस। दिस इज द न्यूक्लियोफाइल CN विच इज इनकमिंग, है ना, ये अटैक कर रहा है ना। दिस इज इनकमिंग न्यूक्लियोफाइल, दिस इज द न्यू न्यूक्लियोफाइल विच इज कमिंग। न्यूक्लियोफाइल क्या हो गया? CN नेगेटिव। नाउ लीविंग ग्रुप कौन लीव कर रहा है? द BR इज लीविंग इन दिस केस, सो इट्स गोइंग टू बी BR नेगेटिव इज द लीविंग। डज इट मेक सेंस? हाँ या ना, जल्दी बताएं। डज इट
जी
मेक
सर।
सेंस?
यस
ठीक है,
सर।
अगले वाले बताओ न्यूक्लियोफाइल कौन सा होगा? व्हाट इज द न्यूक्लियोफाइल? व्हाट इज द
Cl।
Yeah.
न्यूक्लियोफाइल?
And NO2.
NO2।
एंड द लीविंग ग्रुप?
Cl। Cl।
Cl नेगेटिव, है ना, ये इसको लीविंग ग्रुप बोलते हैं। ठीक है, जो निकल जाए। ठीक है, जो निकल जाए पूरा। चलिए, और इधर उधर नहीं देखना है आपको, ध्यान से, ठीक है ना, इधर उधर मत देखिएगा, बस क्या निकल रहा है, क्या ऐड हो रहा है, उसको देखना है बस आपको। आई विल डू द फिफ्थ वन। फिफ्थ और सिक्स हम करेंगे।
Sir, are you supposed to send it to you?
Yes, Mariam and Taha, do you guys need any help?
Sir, are you supposed to send the answers to you?
Yeah, you have to send the answers to me. Oh, my mic was off. Okay. Yeah, you have to send the answers to me. दिस इज मरियम लोहानी, राइट मरियम? या ताहा किसने भेजा अभी? ताहा शायद नहीं, ताहा आपने भेजा ताहा?
Yes, sir.
अच्छा मरियम लोहानी, व्हाट अबाउट यू?
सर वो मेरा फोन अभी मेरे पास नहीं है, मैं आपको 5 मिनट में भेज दूँ।
नहीं नहीं, 5 मिनट में तो मत भेजिए, ठीक है, नो प्रॉब्लम। 24 से 24, जस्ट मैच the answers. So here the क्या करें, न्यूक्लियोफाइल ना, न्यूक्लियोफाइल H negative is the nucleophile, Br negative is the leaving group. Here CH3O negative is the nucleophile, iodide ion is the leaving group. Here the हाँ यहाँ पे लिखिएगा, यहाँ पे Na positive it will dissociate into Na positive and OH negative, ठीक है? So OH negative is going to attack. So OH negative is the nucleophile and you can obviously see Cl negative निकलेगा यहाँ से, Cl negative is the leaving group. But yeah, water cannot dissociate into H positive and OH negative because the dissociation constant of water is very low. You have only 10 to the power minus 14, like you have 10 to the power 14 atoms of water, उसमें से एक atom dissociate होता है, ठीक है? तो the dissociation constant is very low. So the attacking reagent that is the nucleophile is H2O itself, and यहाँ पे Br negative आपके पास क्या है? This is the leaving group. Copy this down, raise your hand once you are done. Oh, Amna got this. Yes, Amna got this.
यस सर।
चलिए देखिए. Now we have seen what happens in the nucleophilic substitution, that Rx plus nucleophile is going to give you Ru plus X negative. So two things is happening. This bond is breaking, the Rx bond is breaking, and the Ru bond is getting formed. ये क्या हो रहा है? This is breaking. And this is forming. यहाँ पे सुनिएगा. So two things happen. Rx bond breaks, and Rnu bond forms. अब ये चीज जो है आपके पास एक साथ भी हो सकती है, आई मीन साइमल्टेनियसली भी हो सकती है, और स्टेप बाय स्टेप कि पहले आर एक्स बॉन्ड टूटे, उसके बाद आर एन यू बॉन्ड फॉर्म हो, ठीक है? तो दोनों को हम लोग एनालाइज करेंगे एंड देन वी आर गोइंग टू गेट सम. ना आई होप दिस टिल हियर एवरीथिंग इज लॉजिकल कि आपके पास दो स्टेप है, दोनों स्टेप एक साथ हो सकता है, आर एक्स बॉन्ड टूटता रहे, आर एन यू बॉन्ड फॉर्म होता रहे, एंड इट कैन हैपन इन टू स्टेप्स ऑल्सो. तो ये सिंगल स्टेप भी प्रोसेस हो सकता है, इन सिंगल स्टेप इट कैन हैपन, और इट कैन हैपन इन टू स्टेप्स. ये दो स्टेप का प्रोसेस हो जाए, ये दो स्टेप का प्रोसेस हो जाए, ठीक है? थोड़ा ध्यान दीजिएगा यहाँ पे. व्हेन न्यूक्लियोफाइल प्लस आर एक्स is going to give you RNU plus halogen atom. ठीक है, एक ही बार में हो गया. न्यूक्लियोफाइल ने अटैक किया एंड द हैलोजन एटम इज लीविंग नाउ. न्यूक्लियोफाइल अटैक्स ऑन द एल्काइल ग्रुप एंड द हैलोजन एटम लीव्स, यू गेट RNU बॉन्ड एंड X नेगेटिव. उस स्टेप में कैसे होगा? सबसे पहले RX में this bond break and it forms R positive, a carbocation, and X negative. Now once the carbocation is formed, then the nucleophile comes and it attacks RNU negative. अब क्या होगा यहाँ पे? RNU bond is going to get formed. Now if you look at the first case, please don't write now, try to understand this point, is very important. यहीं से अगला हमारा पूरा टॉपिक निकलने वाला है. if you look at the single step process, then in that case, nucleophile until and unless it attacks on the alkyl group. What did I say? Mariam Lohani, Taha, and Amna, tell me. What did I say? Bolo, until and unless nucleophile attacks on alkyl halide. जब तक न्यूक्लियोफाइल RX पे अटैक ना करे. What did I say?
Until and unless nucleophile attaches to Rx.
Till then the reaction will not happen. Yes or no? Amna, Mariam, repeat करो भाई. If you don't repeat, समझ में कैसे आए? Amna तो repeat करिए. Yes, Mariam. Until and unless nucleophile attacks the haloalkane, reaction will not happen. That means the collision of nucleophile and haloalkane is necessary. Now, if the nucleophile and haloalkane has to attack each other in order to get the result or the product, then how can we increase the rate of reaction or the speed of reaction? We can increase the speed of reaction by having large number of nucleophile and large number of haloalkane. Then the probability of attacking each other, the probability of colliding with each other gets higher. अब यहाँ पे जो रेट है ना, this rate is going to be dependent on the concentration of nucleophile as well as the concentration of haloalkane. Now, since the rate is dependent on two things, we call it bimolecular nucleophilic substitution. ठीक है. Now, bimolecular nucleophilic substitution is called as SN2. This 2 is for the bimolecular nucleophilic substitution. Bimolecular. ठीक है. अच्छा, what about this case? In this case, if you see, there are two steps. अब इन दो स्टेप में से जो भी स्लो स्टेप हो उस पर डिपेंड करेगा रेट ऑफ रिएक्शन. व्हाई? बिकॉज इफ समथिंग इज फास्ट वो तो जल्दी हो जाएगा. The slow step is going to decide the rate of reaction. If the slow step is very slow, then the reaction will be slow. फास्ट तो फास्ट है ना, फास्ट तो तुरंत हो जाएगा, उसके लिए कोई जरूरत ही नहीं है. If the slow step becomes slightly faster, in comparison slightly faster, then the reaction will happen fastly. अरे जैसे मान, if you have one shirt and you have one jeans, let's suppose t-shirt takes 5 minutes to get to dry, shirt takes 10 minutes to dry, the jeans take 15 minutes to dry. To tell me what will be the total time taken to dry the three clothes, Amna, Mariam and Taha. तीनों को सुखाने में, तीनों को ड्राई करने में कितना टाइम लगेगा?
15 minutes.
How much? Taha? 15 minutes, right? Amna and Mariam, does it make sense? आप लोग को आंसर करने नहीं आता यार, क्या हो गया Mariam? How much
Yes, sir.
time? How
15
many
minutes.
minutes? How many?
15.
15, right? अच्छा, 15 minutes because jeans is taking 15 minutes. Yes or no? Please tell me.
Yes, sir.
अगर फिर जीन्स ने 30 मिनट ले लिया तो अब टोटल टाइम कितना लगेगा?
30 minutes.
How much?
30.
30 minutes, right? So you can see that the slow step is the deciding factor. हाँ या ना बताइए? The slow step is the deciding factor. Does it make sense? Yes or no? Please tell me.
Yes, sir.
ठीक है, तो यहाँ पे भी आप बताइए in the step 1 and 2 which is the first step. कौन सा step slow होगा? The first step will be slow. The second step, yes, tell me.
Sir, first step.
First step will be slow because there is a bond breaking taking place, and the bond breaking will be obviously tough, and it will be what? It will be slower. वो तो actually it is almost reversible because plus और minus जहाँ पे मिल जाए आपको, how can they be far apart? वो तुरंत आते हैं. It is almost reversible. भले ही फॉरवर्ड रिएक्शन थोड़ा ज्यादा होता है because this R positive is attacked by the nucleophile. ठीक है? So please write in this case step 1 is slow and rate determining step, that is why the rate is directly proportional only to the concentration of Rx. जितना ज्यादा Rx होगा उतना ज्यादा आपको reaction fast होगा. Now this is unimolecular nucleophilic substitution, commonly known as SN1. Copy this down, raise your hand once you're done. Just waiting. Okay, next types of SN. SN1, SN2. देखिएगा SN1. It refers to unimolecular nucleophilic substitution. The reaction in which rate depends on the concentration of substrate, that is haloalkane, only is known as SN1. Rate directly proportional to the concentration of haloalkane. And the rate, I mean, this rate law है, ठीक है, this rate law is going to be taught in detail in the chemical candidates. अभी बस इसको लिख लीजिए, सब बाद में समझ आपको. Since rate is directly proportional to the concentration of haloalkane, equal, I mean, if you are going to remove the proportionality sign, तो एक proportion that is K. The order, ठीक है, is equal to 1 and which is also equal to the molecularity. These words are going to be taught in detail in the chemical kinetics chapter. ठीक है, यहाँ तक रखिए इसको. And mechanism जो है in detail we are going to cover it in the next lecture because mechanism short time late.